Okay, we're going to go over the study guide for Chapter 4 for your upcoming exam, either Monday of next week or Tuesday of next week, depending upon whether you're a Period 3 or you're a Period 6 physical science student. Okay, so we're going to go over these one by one, and again, you're welcome to pause it at any time. We're going to kind of cruise through these, and I'm going to emphasize very particular points. So first concept we're going to be looking at is atoms, then we're going to be looking at isotopes and ions, then we're going to be looking at the periodic groupings, and then we'll end with the types of bonds. So going to the atoms, the first question is, what's the size of the nucleus compared to the atom? So first of all, where is the nucleus? The nucleus is a very small part of the atom. The nucleus is the center of the atom. It's in the very middle of the atom. What do you also find in the nucleus are the protons and neutrons. What are on the outside of that are going to be your electrons. So let's go over the size of things. We have your atom is going to be the largest of the structures. And we have your protons and your neutrons and your electrons. These are the three subatomic particles. Where do you find the protons and the neutrons? You find them in the nucleus, in the center of the atom. So here's where you find the protons and the neutrons. Where do you find the electrons? You find them circling around the nucleus. And the electrons are very, very tiny, very, very, very small. So the largest structure is the atom. And then what you get is the smaller structure than that is going to be your nucleus. That contains your protons and your neutrons. And the smallest structure, the subatomic particle after that, is going to be your electron. So there's a numerical value. You don't have to memorize it. But the nucleus, the size of a nucleus compared to the atom, it's about 100,000 times smaller. Okay, than the atom. The nucleus is about 100,000 times smaller than the atom. But just to know that the nucleus is smaller than the atom and the electrons are smaller than the nucleus, which contains the protons and the neutrons. Location, name, and charge of the three subatomic particles. We've got our protons, neutrons, and now we also have the electrons. So we have our protons. You can list this out. We have your neutrons. And we have the electrons. The protons, pro, meaning that's a positive charge. Neutrons are neutral. What has to balance the atom is this negative charge found in the electrons. The protons and neutrons, again, are found inside of the nucleus, as we discussed previously here. And the electrons are found going around the nucleus in what are called shells. We've discussed the first three shells that contain 2, 8, and then 8 electrons. What's the significance of the atomic number? Well, if you look at a periodic table and you look at that atomic number, the number of each atom, that's called the atomic number. The atomic number is equal to the number of protons, and it's also equal to the number of electrons. The significance of the atomic mass. Well, where do we find the atomic mass? All the atomic mass is found in the nucleus. We discussed this in lecture, in the nucleus. The electrons do not contribute significantly to the mass of the atom. They're excluded in the mass of the atom. It's only the protons and the neutrons. So the significance of the atomic mass is equal to the number of protons and number of neutrons. So it's the number of protons plus the number of neutrons. In other words, it's the mass of the nucleus. What makes an atom neutral? Well, what gives an atom its charge? We have positively charged protons, negatively charged electrons. What's going to make something neutral? You have to have the same number of positives and the same number of negatives. Or for this, you have to have the same number of protons and the same number of the electrons. When you have that, you're going to have an atom, a neutral atom. If you have lost or gained electrons, you're going to have an ion, which we'll get to later. How do you calculate the number of neutrons? So here's the calculation. So if you remember the mass, looking at the atomic mass, which is in the nucleus, you're going to take the mass and you're going to round it to what's called the mass number. So it's the rounded atomic mass. So the rounded atomic mass. Okay, round it to the nearest whole number. Okay, this is called the mass number. This is going to be equal to the number of protons plus the number of neutrons, because if you remember, the protons and neutrons, that's the mass of the nucleus. So here's our formula. The mass is equal to the protons plus the neutrons. Okay, how do I solve then for the number of neutrons? Well, I can subtract the protons from both sides. Okay, and I have an algebraic equation here, and therefore my neutrons, number of neutrons is going to be equal to, it's going to cancel over there, it's equal to the mass minus the protons. Okay, take a look at your periodic table. I'm going to give you an example. Go to P, phosphorus. It's element number 15. The atomic mass is 30.974. What would that round to? That would round to 31. What does the 15 indicate? 15 is the atomic number. The atomic number is also equal to the number of protons. So for phosphorus, how many neutrons is it going to have? What number would you have to fill in for here? You can either add it in and mentally say 15 plus what is equal to 31, or you can do this and you could subtract the protons from both sides and say 31 minus 15 will equal, the number of neutrons is going to be equal to 16. So that's how you calculate the neutrons. Draw an atom with neutrons and protons in the nucleus and the electrons in the first three shells. Now, if you remember, the first three shells have the magic numbers of 2, 8, and 8 for those electrons. So the electrons in those first three shells can go 2, 8, and 8. Let's say we have an element such as fluorine. Okay, fluorine is element number 9. That means it has 9 protons. Fluorine has a mass of 19. How many neutrons does it have? Well, if the mass is 19 and the protons, which is the atomic number, is 9, what's the number of neutrons that you have to have? I have 19. I have 9 protons. What does this number have to be over here? Well, if I subtract the 9 from the 19, this will give me 10. It's going to have 10 neutrons. And it has to be an atom, and so therefore it's going to have 9 electrons. Let's draw what this would look like over here with the 3 shells. So in the nucleus, again, our nucleus is composed up of the protons and the neutrons. So it has 9 protons. It's going to have 10 neutrons. And it's going to have shells going around this. How many are going to fit in the first shell? 2. Okay, now of my 9 electrons, 2 went in the first shell. How many will go into my second shell? 7. 2 plus 7 will equal my 9. So that's how you would draw an atom. Calculate the mass of a molecule based upon the mass of each atom and the number of atoms. Okay, now imagine we did this with glucose. And imagine that carbon has a mass of 12. And hydrogen has a mass of 1. Now, if I have the molecule C3H8, this is the formula for propane. If I take a look at my two elements of my carbon and my hydrogen, how many carbons do I have according to the subscript there? I have 3. How many hydrogens do I have? I have 8. So here's the formula. These are the masses. It's the mass number for carbon. It's the rounded number for carbon. So it's 12. Each carbon weighs 12, and I have 3 carbons. So the total mass of the carbons is going to be 36. Now with the hydrogens, I have 8 of the hydrogens. Each hydrogen has a mass of 1. So the total mass of the hydrogens is going to be 8. Well, if 3 hydrogens weighs 36 and 8 hydrogens weighs 8, if I add the 36 and the 8 together, this will give me the mass of the atom, which in this case is going to be 44. So that's finishing the section on atoms. We're now going to look at isotopes and ions. Definition of an isotope. An isotope is a neutral atom that has a different number of neutrons. So there's something that stays the same in an isotope, and that's the protons. So it's the same number of protons. You just have a different number of neutrons. So since we have the same number of protons, we have the same element. A big concept of an element is it's defined by the number of protons. If you change the protons, you change the element, as we did in one of our labs. We went from C14, which was a radioactive carbon, and that decayed into nitrogen. It had a different number of protons, so it was a different element. But if you have the same protons, you're going to have the same element. So it's the same element, it's the same atomic number. Because if you remember, the atomic number determines the number of protons. So it's the same element, it's the same atomic number, but we have a different number of neutrons. Well, if the atomic mass is dependent upon the protons and the neutrons, what can we say about the atomic mass? It's going to have a different mass. Why is it going to have a different mass? Because it has a different number of neutrons, and neutrons are part of the nucleus. And it's the protons and the neutrons that give the mass to the nucleus. What happens if the number of protons changes? We actually change elements. So the number of protons is equal to the atomic number. So if we change the number of protons, we change the atomic number. And if you change the atomic number, you change elements. So that's what happened to C14 when it decayed to nitrogen 14. It had the same mass, but it had a different number of protons, so it's a different atomic number. It changed to nitrogen. Indicate the number of protons, neutrons, and electrons for isotopes of the same atom. So let's take a look at C12 versus C14. So we're looking at isotopes still. So protons, neutrons, electrons for isotopes. Again, isotopes have the same number of protons, different number of neutrons. We're going to take a look at what's called carbon-12.